Hello, my name is Hans Lindetorp and I'm a musician, a music producer, lecturer and researcher in the field of music production for interactive media. And I'm very happy to be a part of ICAD 2021. And today I would like to present our latest paper. It's called Sonification for Everyone, Everywhere, evaluating the WebAudioXML Sonification Toolkit for browsers. It's written by me and my co-author Kjetil Falkenberg. And we are lecturers and researchers at the Royal College of Music and the Royal Institute of Technology in Stockholm, Sweden. About half a year ago, I read the book, The Sonification Handbook. I was very inspired by the visions from the authors about the future where sonification will be a standard method for data display and analysis, and where sonification techniques will be established and standardized. 10 years has passed since the book was written, and arguably we still have a long way to go with a lot of potentials yet to explore. We believe that the more people are engaged and the more sonifications that are created, the better result we will finally get. But there are stumbling blocks. We've discovered that the process for producing like standard music, when we teach that to our students, it's quite a straightforward process of recording, producing and distributing the music to the world. But when it comes to sonification, and especially interactive sonification, it kind of tends to get stuck in the lab, often because of local software and installation requirements that makes it really hard for the masses to consume it. We've also noticed that it requires a lot of different skills from different disciplines if you want to create sonification. So you need to be able to handle data, you need to have an understanding of music and audio production, and also audio synthesis. And often you need basic skills in programming to be able to do something. We want to challenge that, and work has still been done, has already been done. For example, the WebAudio API is a great new standard for web browsers that makes it possible to create an audio application that can be distributed to anyone with a browser. Our students, they don't know programming, so we have created an abstraction to WebAudio API, making it much more simpler for them to create the application. So with WebAudioXML, it's possible to describe the audio configuration in an application using standard XML elements and attributes. And that technology has been presented and will be presented at various conferences like Sound and Music Computing Conference last year and this year, and also the WebAudio Conference this year. So in this study, we present WebAudioXML Sonification Toolkit that builds upon WebAudioXML and WebAudio API. And that is a graphical user interface, making it possible to create mappings for parameter mappings in sonification. And because it relies on the WebAudio API technology, it's very easy to deliver or distribute your interactive sonification to anyone with a browser. And because it builds upon WebAudioXML, it doesn't require any skills in programming JavaScript. We recruited 10 students in order to understand how this application is received and how it is to use it and what it can be good for. And these students, they didn't have any education in programming, they didn't have any specific musical skills or training, and this was the very first time they created any sonification at all. And they were asked to take a data set of their own choice and to use or create sounds that were describing and communicating this data set in a sensible way. They gave us consent to analyze their project files to see exactly what they had been doing to create this result. And they also answered a lot of questions and let us analyze their reflections upon how they kind of experience using the toolkit and what ideas and potential they could see for sonification in general and this toolkit in particular. So this is what the application looks like. And we can now see data for the carbon emission per person for Sweden from 1900 till 2018. And the data is mapped to a noise generator. And the data is controlling the frequency of a bandpass filter and the gain according to the settings here. So these settings will control what we hear when we hit play. Or if we scrub through the values. And we can also add another variable, the states, for example, which is mapped to a sawtooth generator with the frequency controlled by the data. And China, which is triggering samples, footsteps in this case. And the more emission, the faster the frequency of the triggering of the sample. And also we get more reverb and the stereo panning will go toward the center. So we can listen to the composition. And we can switch the display mode to show either relative values within each variable, or we can see how they relate to each other exactly. In order to create the audio generators, the students had to use a standard code editor and build the audio generators or manipulate the ones that I provided in the template file like this. So these lines is the instrument playing the sawtooth. So we can see that it's using an oscillator node, a bichord filter node, and a gain node that can be controlled. And here's the noise, and finally the triggered footsteps down here. And when they were working with the data, they had to use Excel or another spreadsheet program to do that. So what did we learn? Well, first of all, it was a great success. All of the students managed to create their sonification during the project time. And we could also see that they primarily used samples and gain. So they were playing samples and they were controlling the volume of the playback using the data. Most of them expressed that it was a really easy to use program and that it helped them to be creative doing the sonification. They also gave us some critique, thinking that the tool was really targeted towards experts, and that had primarily to do with the area of sound synthesis. So that was completely new for them. So all the different parameter namings didn't make any sense to them at all, like frequencies or bichord filters, stuff like that. Also, they would have expect all the editing to be collected within one application, like working with the data and also creating or duplicating new audio generators. So finally, we think the tool was actually really, really helpful for teaching and learning sonification. It encouraged the collaboration between the students and us as teachers and the students, which was helpful during the COVID-19 lockdown. It also really helped us during the assessment of their work because it was all readable in open text files. We could see a potential for a program like this, like an online sonification workstation, where all these different parts would be integrated with the data manipulation, sound generators, with meta controls, so you can make a complex mapping that appears sort of in one parameter in the GUI and then doing something really clever within the synthesizer audio generator. And finally, we also see a need for like a mixer section where the sound could be mixed within the application. We could definitely see the potential for the open format that could be distributed to any platform, encouraging a really good environment for working with like customers and manufacturers doing sonification applications for sound design. So with that, I would like to say thank you so much. for listening. And all this is open source and available if you follow the QR code here or the URL. And if you find it useful, don't hesitate to contact us. We would be very interested in sharing ideas with you. So thank you so much and have a nice summer. Bye.
There are a few questions. The most upvoting, I believe, comes from Thomas, where he asks, how does this handle data sets that don't have a meaningful sorting along an axis?
That's a good question. So when we built this, this tool, we really focused on the time perspective to create like a composition that we could listen to along a timeline. But then when using it, we realized the potential for that whole kind of mapping something else but the linear curve, but like different values, and to be able to scroll through those values. So it became, I would say, the tool kind of turned for myself into quite an interesting tool where we can have accessing these different values by scrubbing through the values. That was quite interesting. And I think that relates a little bit to Kelly's question about the OSC device input as well. So we could potentially have like a real-time data input from any sensors, I guess, that could communicate to the application via, for example, OSC, which we can't at the moment, but that is one of the things we're looking into, so we can make it into a more versatile tool for exploring really interactive sonification according to pretty much any incoming data. I would say also that you might be interested in looking into the WebAudioXML project as well, which the other papers are about, and you can find links from this project to that project as well. And so that is more of an open framework without any GUI for dealing with mapping data basically to audio configurations. And that doesn't, it supports MIDI in a sense at the moment, but I'm about to add OSC support as well for it.
Regarding the mapping topologies, you got a question about WebAudioXML. Could it actually handle multidimensional data sets?
Yeah, right. So when this project was done, then WebAudioXML could support one parameter to many, one data connected to several different audio parameters, which we can do in this interface. We can have like one sort of big row for one country in this case, mapped to various different audio parameters at the same time. What we discovered that would be interesting would be to do the many to one, which was added to the latest project. So that will be presented at Sound and Music Computing Conference, that project as well. So it's now a part of WebAudioXML to do that. Quite a sort of an easy way of defining how different variables connect to one audio parameter. Hope that answered that question.
Could you make a quick comment about plans for like an evaluation, like in-depth evaluation of the tool study? Bruce Walker has a question. I think it's the first now in the...
Yes, exactly. All right. So, no, we actually, in this study, we just focused on the creators' experience themselves and how, and to be honest with you, I mean, they had never experienced making any sonification and even thinking about making a sonification to express data at all before. And I think most of them answered that they wouldn't expect themselves to use it, to use sonification to communicate. So they're quite traditional in terms of, I think visual graphs are really good for communicating data. So maybe we should do something, I would say, with my music producer or music production students that are kind of working with sounds and audio to express and communicate, and to see what we could, what results we could get when it comes to their choice of making sounds relating to the data. That would be very interesting.